Hi all, I'm Matt. I've just started a role with Weather of the 21st Century last month. Previously I was at BOM, and that's what my poster is about, some of the work that I did there to improve the representation of cities in our regional models. So I basically just make the case that the default configurations can be improved, have a series of case studies from 12-kilometre resolution down to 100-metre resolution. So if you're setting up a new model domain, come and chat with me. I might be able to help you represent weather and climate in cities a bit better. So yeah, thank you.
Hi everyone. So this year, ACCESS-NRI is establishing a few new teams. One of them is the software transformation team. So if you want to know what we're working on, I'll just come and have a chat with me. We'd also love to hear how can we help you. And since it's a new team, we are currently hiring. So if you know either someone that is good at optimizing software or knows AI/ML, please let them know. Thank you.
Okay, so typically when we use climate model output, what we do is we take whatever phenomenon we're interested in and we evaluate whether our climate model can represent observations well. And so here on this slide, you can see two climate models for the standard deviation in the El Niño Southern Oscillation box for different months of the year. And if we looked at the model on the left, we might say, well, that model's not very good. It doesn't look like observations at all. The observations being the yellow line and the model being the boxes. But if we look at the model on the right, we might say, well, this model's great. It looks much more like the observations. So plot twist, this is the same model with the same external forcing. The only difference is the initial condition. And this shows us why it can be really important using large ensembles for model evaluation. And so my poster will show you some of the tools that my collaborators have developed on how to do that, and some of the ways we go about evaluating these types of models against observations. Thanks.
Hi everyone, my name is Paige Martin and I lead the user training team at ACCESS-NRI. So my poster, you'll find out a little bit about what our current training program entails, but mostly it's an interactive poster, so we want to hear from all of you. So come on by, bring your thinking caps. We have pens provided at the poster. You can write in your ideas for what you think training should look like in the future. And we also have stickers. If the idea that you had is already written there, you can add a sticker to say, yes, I want more of this. So come on by, say hi, it'd be great to see you. Thanks.
I also have a poster I'd like you to write on, and mine is near Paige's, so you take a pen from her poster and come and write on mine. We're looking at the experiments that we need to do for CMIP7, the early ones, the fast-track ones which are trying to target the IPCC work. I've marked on here the ticks and the question marks of the experiments we've kind of got in mind at the moment, but there's a few gaps there and we don't think we'll manage to do anything, but if you'd like to contribute and help us do any of those missing experiments, I'll be at the poster, so come and talk to me.
Hello, I'm Tammas Loughran from CSIRO. It's becoming increasingly clear that in order to meet the Paris Agreement targets, we need to remove CO2 from the atmosphere. Current strategies rely heavily on the natural land sink, such as by forestation, but it's unknown how much CO2 this could remove or what the effects would be on the climate. We've done global-scale forestation experiments using ACCESS ESM 1.5 by expanding forest lands at the expense of croplands. On the left here, I have a diagram of the experiment branching structure, which uses SSP 585 scenario to create a range of stabilized climate, global warming levels by switching off CO2 emissions. And then on the right, I have the resulting atmospheric CO2 concentrations, and also the CO2 concentrations from the forestation experiments at year 400. In my poster, I show the climate effects specifically for Australia, and if you want to know more, then please come and speak to me.
Hello, I'm Gatti from the ACCESS-NRI. Everyone, I have breaking news. Robots are coming for our job. And today they've come for climate modelling, configuration management and testing. Super niche, I know, but its time is now. So maybe it's not such a bad thing. Needing a developer to verify menial configuration, metadata, and repro testing every time a configuration is modified, it's slow, it's error-prone. Robots, or in this case, GitHub-based automated testing workflows, can do it better. So common metadata errors vanish, users know when scientific answers change, and the process for updating and versioning configurations is quick and reliable. So come and see how we embraced our new automated overlords at our poster.